So a lot of you in your lifetime of being nerds probably come across this equation, e to the pi I plus 1 equals 0. This is Euler's equation, and it's often touted as being gorgeous and beautiful and ties together all these famous constants, e, pi, I, 1, 0, they're all really integral to the concept of mathematics, and everybody says that it's the most beautiful equation in mathematics. I might disagree, there's some other good ones, but a lot of people who argue about how nice it is and how good it is, on the internet at least, I'd say about 50% of them don't even understand it, they just know that it exists. So I thought what I might do is, over the course of about 4 videos, not all in a row, I'm going to spread them evenly over the course of VEDA, I will explain to you what this equation means. I think I can do it in 4. So if you hold on to your hats, we're in for a wild mathematical ride, and hopefully you should come out the end of it feeling, slightly more informed. So, yeah, enjoy. The first step on our journey to understanding Euler's equation is to define angles better. Now what do I mean by this? I don't know what an angle is. It's sort of that shape when you bring it down really small. Well, we can argue all day whether angles are actually a really small shape or whether they're the amount of turn you have to go through or something like that. I've always found them quite loosely defined. I'm sure there's some rigorous definition out there. But I'm sure there's something we can all agree on, and that's that angles, measured in degrees, pretty silly really. I mean, why 360? Why do we need 360? It's something to do with the number of days in a year or something like that. It divides quite nicely into 2 and 2 and 2 again, and 5 and 3 and 3. It's got quite nice round prime factors. But defining a right angle as 90 degrees is quite unnecessary. We don't need things to divide into whole numbers anymore. We're not children anymore. We've got calculators, and they can store numbers to, a high number of decimal places. We don't need to think about things like this anymore. So there's a better way to define angles, and it actually makes angles work with calculus as well, which is a pretty neat trick, and it's called radians, and it works like this. What you do is you find the centre of a circle, and you draw out the radius like that, and make this length 1. So this is a circle with a radius of length 1. And then you draw an arc around the edge of the circle that's also length 1, connect that up, and you say that this angle here is 1. This is 1 radian, this angle here. And this has a lot of implications. Firstly, you might be thinking, well okay, so if that's 1, then how many are in a whole circle? Well, in a whole circle there are 2 pi radians. 2 times pi radians. Notice the pi in here. You might be thinking, oh, Euler's equation's got a pi in it, that's got a pi in it. Oh, very astute of you to see that. And I'm sure we'll understand later why this pi is important.